Good morning, folks. My name is Jason Johnson. I'm the UK and Ireland Sales Manager for B&R Industrial Automation. And today I'm going to extol the virtues and the benefits of Mechatronics and integrated solutions. So first of all, we're all still awake. You enjoying the show so far? Not mine, the overall thing. Yeah? Yeah? Okay. Going to open with a quick question to somebody I can pick on. This lady here on her phone. What's the coolest thing you've seen so far at the show? Okay, so from that answer, I know you haven't been to stand 109 and seen the B&R 6D system. Okay, so go there after that. So, Mechatronics then. The drivers, everybody's talking about Mechatronics solutions at the minute, and it's not just because we've made a word up that we think is great. It's because there are absolute drivers globally for this. It's about individualization. Every consumer these days wants what they want, designed the way they want it, and they want it yesterday. Okay. Now, unfortunately for us as manufacturers of automation equipment and systems, we like things that do the same thing over and over again because they're easy to set up, right? Customers want, they want sustainability. They want to know the companies they're buying from have the right corporate social responsibility platforms, and that all feeds into their supply chain and their machinery. We've got problems with labor. The access to cheap labor in this country has gone away. Everybody wants higher paid jobs. They want jobs that are more fulfilling. So we've got to provide solutions which take care of that and bear that in mind. Digitization, artificial intelligence, all these buzzwords, they're all things that are starting to influence everything that we do, whether it's be driving a car, whether it be creating pretty pictures of your dog with a Christmas hat on through ChatGPT or whatever else. But it's starting to filter through into what we do as an automation manufacturer and what you guys do as machine builders. And then the main one, uncertainty. I've never known a time in my 28 years on the planet of when the things have been so uncertain. Whether it's global wars, whether it's pandemics, whether it's supply chain access, whether it's countries locking down access to components. We just don't know from one day to the next what the situation's going to be. From a machine solution point of view then, we've got to make our machines easier to design, easier to code, easier to use, easier to commission. We've got to give thought to this whole connected along and through the machine lifecycle piece. So when we talk about along the machine lifecycle, we talk about from a blank sheet of paper, the design of that machine, what that looks like, how it uses raw materials through the entire life of the machine and how long it lasts. And then in the vertical connected through, the machine is part of a line, is part of a factory, is part of an entire ecosystem. And the kinds of data and information exchange that go along with all that, and how do we contextualize it and make use of it and analyze it to make the next set of machines better. We talk about flexible transport systems. I already mentioned there a little bit tongue-in-cheek about the 6D system from B&R being the coolest piece of technology here. But it's things like that. It's that kind of technology, these intelligent transport systems, which are very, very flexible and integrated as a part of the process of the machine to get away from, we do something on this machine here, and then we move it to this machine over here, and we do something, and then we move it to this machine over here, and we do something else. What we want are transport systems that become part of that overall process and give you more flexibility. Do more with less, quicker. We also want to be able to have more visibility into the systems these days. We want to know what the machines are doing. We want to know, are we actually at the optimum productivity of each piece of equipment and each asset? So that's about getting not just simple system information back as, is it running, is it not running, how many are good, how many are bad. It's, is it running, how long has it been running at that level for? If those parts are good, great. If those parts are bad, why are they bad? Why are they bad, and does somebody have to intervene, or is it bad and the machine understands what the problems are and can sort itself out and very quickly respond to those kind of changes and be self-supporting and self-healing. Robotics integration. There's a lot of robots dotted around the place here. And it's always been, we have a machine and we have a robot. What we want now is to have a robot which is part of the machine system. It just becomes part of it, just like a servo drive does or like a camera does. It's part of that machine ecosystem. It's not a bolt-on, because when it's a bolt-on, it's then something else that's got to be supported. It's got to be something else that's specially programmed. You need a robot programmer to look after that. If it's part of the machine, it becomes part of the general ecosystem. And then, of course, cybersecurity. We'll all have heard of the Cyber Resilience Act that's coming in at the end of 2027. And how that's going to impact everything that we do. We've seen cyber attacks in many forms. Just most recently the JLR one. Before that, this year we've had the Co-op hit. We've had Marks and Spencer's hit. The impact is huge. And somebody said to me at a show similar to this earlier in the year, yeah, but it's a machine. People don't attack machines to get bank details. No, they don't. But if you've got a production line that's producing pharmaceuticals, that's producing medicine, that's keeping people alive, and people want to be malicious and start saying, you know what, we've hacked into your machine and we're now changing the recipe for that particular product, and you can no longer guarantee that the product going out the door is what you think it is. That's far bigger than whether they get my bank details or not. So what are mechatronics? So a mechatronics solution, basically, it's an integration of all of the disciplines that we've known and loved and played with over the years. So electrical systems, mechanical systems, robotic systems, computer engineering, high-level data integration, vision systems. That entire ecosystem is a mechatronic solution. It becomes a mechatronic solution when those things are brought together in one environment and treated as a single system rather than things that are bolted together to make it work. Smartphones cannot be manufactured without having mechatronic solutions. It's just not possible. The process, the production lines are integrated. So what do we mean, and what are the components then of mechatronic solutions? So we talk about simulations and digital twins, and they are fundamentally different. So simulations have been around for a long time. You produce a model of something, you run it. Does it do what you thought it was going to do? Yes, no, we make some changes. Does it do what I thought it was going to do? With a digital twin, it takes that a step further. And it allows you then to feel real-world information from physical items back into a digital model. So the system's now not running on theoretical data. It's actually running on real data. We were involved in a project a couple of years ago where we basically had a production line, physical production line, and a digital twin of the line. And what we started doing was introducing new modules and additional machines into the digital twin, and then feeding that data into the physical line to see what would actually happen and to see if we got the production throughputs that we thought we were going to get. And what we generally found was you introduce something to solve one problem, and it moves the problem somewhere else. Now, if you can do that in a digital twin, it's very cheap and very easy to see where you're moving your problems to. It's very expensive to buy a new machine, put it in, and realize that you've cocked up your production system somewhere else down the line. So I mentioned before about track technologies and mechatronic transport systems, intelligent transport systems. We at B&R have got 3 different variants of this product. All good for different reasons. First one is our super track solution. High payload, individually controlled shuttles. So you go away from an index and kind of idea where you do something at this point for 3 seconds and then everything moves along and does the next thing for 3 seconds and everything moves along. The real world's not like that. Not everything takes the same amount of time. SuperTrack allows you to move the shuttles individually, high payload, high accuracy. Downside of SuperTrack is that it's a loop-based system. So whether it's an oval or whether it's a square, can you have a square loop? I suppose technically a square loop. But it's a loop-based system, so your shuttles ultimately always go around this loop. The step on from there is Acapos track. An Acapos track is an adult version of Scale Extrix. It's brilliant. Anybody who's any kind of automation geek loves the thought of Acapos track. You get a selection of straights, bends, curves, and you can figure them any way you like, any shape you want. More than that, you can stack them off so they're not loops. So we have electronic divert at full speed with this system. So you can move shuttles from one loop to another loop. So then you've got figure eight possibilities. You've got offshoot possibilities. You've got the ability to rotate shuttles through 180 degrees to take them off a track and bring them back on in the opposite rotation. So you're rotating your parts as part of the transport. You don't need a separate mechanism to rotate parts. Add to the fact that you can run those kind of shuttles at 4 meters per second, that's pretty quick. They're all controlled individually. So you can move them one at a time, you can move them all together, you can make them going backwards, forwards, any which way you like. Now, if you think about the step from having a transport system like that to being a mechatronic integrated solution, how do you code shuttles coming from one loop onto another loop and then understanding when you want to bring them back into the first loop at 4 meters per second? You imagine the code involved to write to be able to track and merge and divert shuttles. These systems, by virtue of the fact that they're making use of the computational power of the mechatronic solutions, means you don't have to do that. The system takes care of it. You tell the shuttle where you want it to be, the system will get the shuttle there when you need it. Next track on from that is a 6D solution, which we do have on stand 109, and I do urge you to go and have a look at this thing. It's not magic, it's maglev technology. So we have a series of shuttles which we can fly at various heights, 0 to 4 mil from the surface. And it's 6D because we have 6 degrees of motion, X, Y, Z, pitch, yaw, roll, and rotation of these systems as well. Okay. I had a discussion with a guy earlier this morning. It's more about moving the part rather than moving the tooling. Okay. If you've got something where you need 5 micron accuracy, so CNC accuracy, but you don't want to start introducing additional XYZ axes, then this system's perfect. You can move the part around under whatever process you need to do. You can swarm shuttles together so you can carry higher payloads. Great for if you've got a production line which produces 80% of a part which weighs 800 grams, for example. And then every now and again you've got one part which weighs, I don't know, 1.2 kilograms. Great. Use the small shuttles. You don't need special tooling because when you want the heavier product, you swarm 2 shuttles together and you share the load across 2. And it's this kind of flexible thinking that's important with mechatronic solutions and about getting away from transport solutions being seen as I said earlier, moving from one place to another. It's about being part of the solution. I mentioned already about integrating robots as part of the solution and not having robots seen as a separate thing. Our machine-centric robotic solution concept basically has the robot programmed through the PLC control system of the rest of the machine. You don't need an additional robot controller. At the end of the day, what is a robot? It's some servo drives and motors. But we control servo drives and motors with PLCs every day of the week, so why not just connect them to robot axes and do the same thing? You do things like that, you start getting away from needing additional sensors to understand where things are because it's all controlled and programmed in one place. You've got a very dynamic structure and the system knows where everything is without additional sensors and without the delays that that brings in. So it's a more robust system and it's a faster system. The next piece of that puzzle is integrated vision. So we use vision in almost all machines. You get something here, you want it inspected, so it makes a sensor, you take a picture, system processes the image, you get a good, bad, whatever, on you go. In mechatronic solutions, you don't need to do that. The system, it's all programmed in the same environment, so you don't need a sensor to tell you when a shuttle's in the right place to take a picture. You know where the shuttle is, so you can trigger the camera at the right time. Well, that's great. Is that a bit gimmicky? No. Because if you've got a machine that varies in speed, anybody who's set up vision systems know they're a pain in the backside if you've got a change in speed. Because from when you get the signal to when you take the image, that time varies depending on machine speed. So if you've got a very slow speed line, and you come in and you take an image, with a traditional sensor, you've got then speed that machine up. By the time the shuttle comes in and goes away, you haven't made the sensor, you haven't taken the picture, and it's a waste of time. With a dynamic mechatronics solution, you know exactly when that shuttle is going to arrive in the right place to take the image, and you can trigger the camera to do that. We have a demonstrator in Milton Keynes which runs a system at 5 meters per second, and the camera has no external sensor. We can run that thing really slow, we can run it at full speed, and we never miss an image. Okay. Add to the fact that with our vision system, the lighting is integrated into the camera head itself, and then you can strobe different colors. So now you don't have to do different setups if you've got different color products that you're looking to. You can strobe different colors as part of your process. Really flexible. The final piece to the vision system from B&R, which is really nice, and again, this is me looking at it from a control systems engineer. If you junk a camera, if you kill a camera, you take the camera out, you plug in a new B&R camera, and you don't have to do another setup, because all of the setup parameters are stored in the PLC program along with all of the rest of the PLC parameters and the rest of the machine parameters. And because the cameras are factory certified, we guarantee you plug the same type of camera in, it will download all of the settings and it will run out of the box. And that's pretty unique. And then, of course, the final part to this whole ecosystem is the digitization. Getting that data from the machine into the cloud generally, whether that's an on-premise solution or off, get that data, contextualize it, make use of it, analyze it, improve your processes. Okay. We have, again, edge controllers, which are part of the X20 range, which just sit in quite happily in your PLC rack and become, again, part of that whole ecosystem. If you're going to be successful with Mechatronics, you need a solution which can tick all of the boxes for all of these various parameters without having to dive between different types of software packages, different types of data analytics packages, different types of motion control solutions. Do it in one place. Do it with B&R. Come and see us on stand 109 if you want to have a bit more of a chat. We've got a few guys over there, and like I say, we've got a 6D solution over there for you to look at as well. Thank you.